Hello guys, good evening everyone. Good evening guys. So please tell me about audio and video. Is it clear? Because from my side it's clear. Okay, it's clear from my side. I think it should be clear from your side as well. Okay, so I hope you are well and you are preparing everything well. So your preparation is going well. So today we are going to start one interesting topic, that is Nyquist plot. So there will be approximately 4 to 5 sessions on this Nyquist plot. So I'll start from the basic. I'll start from zero level and I will take you to the top level. But the thing is, you have to follow me. You have to attend all the lectures. First time I'm going to complete this topic on YouTube, because this topic is not available on YouTube from my side. If you find a Nyquist plot on YouTube, I have taught this topic in parts. Some topic you will find somewhere and then other topic you'll find somewhere else. So it's not completed on YouTube from my side. So today I'm starting one 4 to 5 lecture series, and in this series I will try to cover up this topic. Okay, so it is again very interesting topic, and from zero level to the top level we will try to cover up. The timing of the class will be same, 9 p.m. and I will take approximately 30 to 40 minutes on each class. The class length will not be that much long, like 1 hour or maybe 2 hours. It will not be like that. So I will try to cover I will try to take only 30 to 40 minutes. Okay, and the timing is at 9 p.m. So under this monsoon series we are covering this topic. Okay, and I have asked you about the voting. If you remember, on our Telegram group I asked you to vote for the topic. So you have voted for Nyquist plot, and now it's time to complete for this plot, and then we will try to complete the controller part as well. Okay, yes, controller will start after Nyquist. Okay, because first 4 class will be on Nyquist and then next 4 class will be on controller. Okay, so it is like this. The thing is, I need your attendance, I need your patience, I need your dedication. So you have to attend the live lectures, you have to watch the live lecture, and you can ask me your doubt. The thing is, you have studied Nyquist plot from some, let's say some other place. Okay, let's say some from others faculty you have studied Nyquist plot. So you might have some little bit of information about this plot. Now that information may be hurdle for you. What you need to do is, you need to be free mind. Okay, I mean, just leave that thing apart. Don't try to memorize that previous thing. Okay, it's my request. Then only you will be able to understand my concept, because my concepts are little different. So the only way to understand my way is to, you can say, you have to leave that part, that the previous thing that you have studied from some other faculty. So you have to leave that. Maybe, I'm not saying that he or she may be wrong or maybe correct. I'm not saying that. But what I'm saying is, to understand my concept, you have to leave that part, because I know how the people teach, and then I don't want to categorize it. Let's try to understand it in a basic way, and then we'll go to the top level. Okay, so let's start the session, guys. Before that, Pramit Banerjee is saying, thanks sir for your guidance. I got selected in control system in IT Kharagpur. Okay, got selected in NPCIL. Okay, both are fine. I mean, if you join NPCIL or control system at IT Kharagpur, both are fine. Okay, best wishes from my side. Okay guys, so let's start the session. Let's first cover the introduction part. This is my introduction. My name is Asu Jangra and I teach almost every subject. Now I'm teaching you control system. There is free workshop on 18th of July, which is tomorrow at 7:30 p.m. You can join this free workshop. This workshop will be taken by Rakesh Talreja sir, and the topic is how to get 15 out of 15 in aptitude. Okay, so it is important. You can recommend to your friends also. Okay guys, so let's start. First thing is mapping. In Nyquist plot, you must be clear about mapping. Nyquist plot is all about mapping, believe me. If you know mapping, Nyquist plot is over. Okay, so first let's try to build up some concept. Let's try to build up some basic points. So using this concept, we will try to conclude, okay, we will try to conclude something. So let's try to understand. Let's say there is a S-plane contour is given. This is S-plane. So in this S-plane, this axis is real axis and this axis is imaginary axis. Okay, this axis is imaginary of S. Now there is one contour which is provided to you in S-plane. It's a random contour. I have taken it random. Okay, and the contour is like this. Let's say the arrow is, I'm taking the contour direction in this. I mean, you can take it opposite direction as well. It doesn't matter. So this is some general contour. Okay, I have taken some general contour like this. And now what I want to do is I want to map this contour in TS plane. TS is some function. TS is some random function. Okay, TS is some random algebraic function like this. Okay, now I want to map this entire contour in TS plane. Now this is the real of TS and this axis is imaginary of TS. Now how to map, guys? How to map? Mapping is very simple. What you need to do is first you select this point. On this contour you have to take each and every point, okay, and you have to put it here and calculate the TS value. Calculate the real and the imaginary part of the TS and show it in this graph. It's very simple. But the problem is we cannot map entire infinite points because there are infinite points on this contour. So let's select some selected points. I have selected this point, I have selected this point, I have selected this point, and this point. Let's say I have selected these 5 points and I want to map these 5 points in this TS plane. So the first point is select this point, take S equal to 1. At this point S, the value of S is 1. So what you can do is you can choose this S equal to 1 and you can put it here. So if you are putting here as S equal to 1, it will become 1 by 3. It means this point can be mapped at 1 by 3 in TS plane. Okay, so let me show it here. This is 1 by 3. Okay, this point is 1 by 3. So what I have done is I have mapped this point at 1 by 3. Now it's time for the next point because you are going in this direction. You have selected some direction of this contour, S-plane contour. So now the next point is 1 plus iota, 1 plus j. Now if you put S equal to 1 plus j, then what is the TS value will become? TS value will be 1 over 1 plus j plus 2. So it will become 1 over 3 plus j. It will become 1 over 3 plus j. Now you have to calculate the real and the imaginary part. So if you realize this, if you multiply and divide with 3 minus j divided by 3 minus j, if you multiply and divide with the conjugate of this, you will get 3 minus j divided by 10. So it will become 0.3 minus j 0.1. Okay. So now the mapping of this point will be the real part is 0.3, real part is somewhere, and the imaginary part is j.1 minus j.1. So the point will lie somewhere here. Somewhere here the point will lie. Okay. Okay guys, fine. So we found the mapping of this point. Now the mapping of this point. Let's calculate the mapping of this point. How to find the mapping of this point? Where this point will be mapped in this TS plane? What you can do is you can put S equal to j only. If you put S equal to j only, it will become 1 over 2 plus j. 1 over 2 plus j. S is j, na? Iota. So now you can do the realization process. So if you do the realization process, it will become 2 minus j divided by 5. Okay. So it will become 0.4. The real part is 0.4 minus j 0.2. So the real part is 0.4 and the imaginary part is minus j.2. So the point will lie somewhere here. Okay, the point will lie somewhere here. Is it clear, everyone? Okay, so you can see that this point is mapped here at this position. Real part is 0.4 and the imaginary part is minus j 0.2. Now let's come to the next point is minus 1 plus j. So if I put s equal to minus 1 plus j, it will become 1 divided by 1 plus j. And if you do the realization process, it will become 1 minus j divided by 2. It means the real part is 0.5 and the imaginary part is also 0.5. So the real part is 0.5 and the imaginary part is also 0.5, somewhere here. Okay, I'm showing randomly. Okay, so this is 1 by 3, so it will be 0.5. 1 by 3 is 0.33. If this is 0.33, this will be approximately 0.5, and this is minus j 0.5. Okay, the downward direction minus j 0.5. Now let's come to this point. What is this point? If you map this point here, s equal to minus 1, it will become plus 1. Okay, so it will become plus 1. So how to show it? Let me show it. Okay, it will become plus 1. Plus 1 means it will be somewhere here. Okay, now let's draw it. Let's draw. Okay, so this is the contour. This is the contour in S-plane. Since you are moving in this direction, so it is moving in this direction. Now you have to map this part also. But we know that this is symmetric. This is symmetric. This is the conjugate part of this. You can see that this lower part is the conjugate part of the upper part. So what you can do is, you can replicate this graph. Okay, I mean, in similar way you can replicate this graph. Is it clear, everyone? Tell me. So in similar way you can replicate this graph and it will be like this. Okay, so this is the final mapping. I hope you understood it. So this S-plane contour is mapped into TS plane, and the final TS plane contour is like this. Now let's come to the next part. I'm not going to conclude anything. I just have mapped this S-plane contour into TS plane. Okay, now let's leave it apart. Let's leave it. Let's come to the next question. Next question is again similar. The thing is, now I have to map this S-plane contour in this TS. TS is some random function, let's say. Now I want to map this S-plane contour into this TS, and the S-plane contour, the direction of this S-plane contour is like this. Okay, direction is, I'm taking the direction like this. You can take the direction as anti-clockwise or clockwise, it's your choice. Okay, and I have selected 1 point, 2 point, 3 point, 4 and 5 points, and I want to map these points in this TS plane. Let's do it. Okay, let's do it, guys. So this is my TS plane. This is my TS plane, and we have the real part and the imaginary part. Now first of all, select one point, this point, and map it in TS. Tell me what is the value. If you map this in TS, you will see that it will become 1 by 3. So you can show the point at this position, 1 by 3. Okay, so the mapping of this point will lie here, 1 by 3. Now let's take this point, 2 plus j. So if you put 2 plus j here, it will become 1 over 3 plus j, and you can simplify this, 3 minus j divided by 10. So it will become 0.3 minus j by 10. Okay, previously it was s plus 2, now it is s plus 1. Okay, minus j minus 0.3 minus j 0.1. So 0.3 is somewhere here, and so the point will lie somewhere here. Now let's come to the next point. Next point is j. So in place of s you can put j. So 1 over j plus 1. It will become 1 minus j divided by 2. Okay, so in real part is half 0.5 and the imaginary part is also 0.5. Somewhere here it will lie. Okay, somewhere here it will lie. Now the next is minus 2 plus j. If you put minus 2 plus j here, it will become 1 over minus 2 plus j plus 1. So it will become minus 1 plus j. Okay, now it will become minus 1 minus j divided by 2. Okay, minus 1 minus j divided by 2. It means the real part is minus 0.5 and the image, so it will lie somewhere here. It will lie somewhere here. And the next point is minus 2. If you put minus 2 here, it will become minus 1. It will become minus 1. So the graph will look like this. I mean, the contour will look like this. It's a rough contour, guys. So I have plotted the contour for the upper part. The lower part is just the imaginary version. It's just the conjugate version of this. Okay. So what I can do is, I can replicate this. I can replicate this. Okay. So it's easy peasy. Yes. and the arrow will be like this. Okay, so this is the contour. So if you want to map this S-plane contour in this function, the final result is like this. Now let's come to the next. Let's come to the next. So now I want to leave it. Okay, just leave it, guys. Just leave it. Let's come to the next. Next is this contour. Again, S-plane contour, and I'm taking the S-plane contour like this. Okay, so there are 5 points I'm taking, and the contour direction is like this. Okay, and I want to map this S-plane contour into this function, TS function. Okay, let's see the result. Let's see the result. TS plane. Okay, let's see the result. Now tell me. First of all, you have to map this 2. So if you map this 2, it will become 3. Okay, it will become 3. So somewhere here, let's say this is 3, point number 3. Now 2 plus j. If you want to map this 2 plus j, it will become 3 plus j. Okay, it will become 3 plus j. Here. Now j. If you put j here, it will become j plus 1. 1 plus j. It will become 1 plus j. So it will look like this. It will look like this. Okay, it will look like this. You can see that minus 2. If you want to map minus 2, wait a minute, guys. I made a mistake. Okay, let's complete. No? So 2, I have mapped 2 at 3. Now 2 plus j, it will become, real part is 3 and imaginary part is j. Now j, it will become 1 plus j. Okay, 1 plus j is, this is 1, 1 plus j is somewhere here. Okay, fine. Now the next is minus 2 plus j. If you want to map this minus 2 plus j, it will become somewhere here. So the graph will look like this. The graph will look like this. Okay, this will be the graph. Perfect. Okay, this is minus 1. This is the graph, because you are moving in this direction, so you are moving in this direction as well. Okay, I hope it is clear. Okay, now again let's leave it. Let's come to the next. Next is this. Now what I want to do is I want to map. Let's not take 2 here. I want to map into S plus, or maybe S plus 3. Let's take S plus 3. Okay, so I want to map in this. Now tell me, guys, how to map. It's very simple. Again, you take the direction like this. Okay, this is the S-plane contour, and you select the points and you can map. And you can map all these points. So let's map it in TS plane. So things are very repetitive, things are very easy. Okay, things are very repetitive, things are very easy. If you map it, the resultant graph will look like this. You can map it yourself, and the resultant graph will look like this. You can see that this point will be mapped at 5, and this point will be mapped at 1. Okay, so the graph will look like this. You can see yourself. This is the mapped graph, and this is TS plane. This is TS plane. So what we are doing is we are mapping the S plane contour. This is some S plane contour. These are the values of S. Okay, on this contour we got the values of S, and we have taken those values and we have mapped those values into TS. Okay, so we have mapped the S plane contour into TS. Okay, TS plane. So we have done 4 questions, 4 mapping, 1, 2, 3 and 4. Now it's time for the conclusion. Now let's look at the conclusion. Why we are mapping this and what is the conclusion? Okay, let's look at the conclusion. First of all, look at this graph. This is the first mapping we have done. And this function has one pole at -2. Let's show this pole. Let's show this pole. If I show this pole s equal to -2, it will lie somewhere here. -2 location. In the next mapping, the pole is at -1. -1 will lie here. The pole is at -1. In the next mapping, the 0, there is no pole here. Only 0 is there, and 0 is at -1. At -1, you have the 0. And in the next mapping again, the 0 is at -3. -3, we have 0. Okay, so I have shown the poles and the zeros location. Now, after showing the poles and the 0 location, check how many poles or zeros inside this contour, S-plane contour. no pole or zeros of this function are inside this contour. It means if the pole of this function or zeros of this function are outside this contour, and if you do the mapping in TS plane, if you map this contour in this TS plane, then there will be no encirclement of origin. No encirclement of origin. You can see that. If you map this S-plane contour into TS plane, the origin is not encircled. There is no encirclement of origin. The contour is outside. It's not containing the origin part. Why not containing? Because the poles and the zeros of this function are outside this contour. Okay? If the poles and zeros of TS are not inside this contour, it means if you map this S-plane into TS plane, then there will be no mapping or no encirclement of origin. There will be no encirclement of origin. Just remember this point. Now look at this point. In this, you can see that only one pole is inside this contour. If one pole is inside this contour, it means the origin will be encircled. The origin will be encircled, and origin will be encircled one time, because only one pole is inside this contour. If one pole is inside this contour, in the resultant mapping, this S-plane contour is mapped into TS plane, and this mapping will encircle the origin one time, because one pole is inside this contour. It will encircle the origin one time. Moreover, it will encircle oppositely. Oppositely means previously in S-plane it was anti-clockwise. You can see that. And since one pole is inside this, one pole of this function is inside this contour, the origin in TS plane will be mapped one time, because one pole is inside, and the direction of the encirclement will be opposite to that. Because of pole, if poles are inside, the direction will be opposite. Okay, so if it is anti-clockwise, it has to be clockwise. You can see that. Okay, there is one encirclement, and the encirclement is in the clockwise direction. Okay, so you have to be very clear about it. Now let's move to the next case. Let's move to the next case. In the next case, you can see that 1 0 is inside the contour. If 1 0 is inside the contour, again there will be one encirclement of origin. There will be one encirclement of origin. In the resultant S-plane mapping, in the resultant contour, if you are mapping this S-plane contour into TS plane, there will be a resultant contour, and that resultant contour will encircle origin by one time, because 1 0 is inside it. And since 0 is inside the contour, 0 is inside this S-plane contour, so the direction of this TS plane contour will be same. Direction of TS plane, if it is anti-clockwise, it will remain as anti-clockwise. It will remain as anti-clockwise. Okay, I hope it is clear. I hope it is clear. Okay, so if 1 0 is inside this contour, it means the number of encirclement of origin will be 1, and the direction of encirclement will be same. Direction of encirclement will be same. Okay, same as this S-plane contour. Same. Okay, so you have to be very clear. If poles are inside, direction will be opposite. Direction will be opposite. Okay, you can see the direction is opposite. If zeros are inside, direction will be same. Direction will be same. Okay, and the number of encirclement will depend on the number of poles and zeros of TS. The number of poles and zeros of the function which are lying inside this S-plane contour. On that number of poles and zeros, the number of encirclement of origin will be decided. Okay, so it should be very clear. Now let's come on the next. You can see that in this function there is 1 0, and 1 0 is outside the contour. There is no pole or no zeros of this function inside this contour. If there is no pole or no zeros of this function inside this contour, it means the origin will not be encircled. You can see that origin is not encircled here. Okay, so it should be very clear. It should be very clear, guys. So this is the conclusion. It means the number of encirclement of origin you can calculate, and that number of encirclement of origin can be either P minus Z you can write, or Z minus P you can write. You can apply either this formula or this formula. Now, whether I apply this formula or this formula, I mean, encirclement has to be positive. We have to find N to be positive. We have to find N to be positive. Okay, if n came positive from this expression, you can apply this formula. If n is positive using this formula, you can apply this formula. Okay, let's say z are more than poles, zeros are more than poles, zeros inside this contour are more than the poles, then we will use this formula. If poles are more inside this contour than the zeros, then we will use this formula. It means n has to be positive. We want n to be positive. Okay, we want n to be positive. I hope it is clear. We want n to be positive. N has to be positive. Either you use this formula or this formula, it doesn't matter. Now the next thing is, if you are using this formula, it means poles are more than zeros. And if poles are more than zeros, the direction of the encirclement will be opposite. Direction of encirclement will be opposite. Direction of encirclement of origin will be opposite. And if you are using this formula, it means zeros are more than poles. Inside this contour, zeros are more than poles. It means the direction of encirclement of origin will be in the same direction. So it doesn't matter whether you are using this formula or this formula. The only thing is you have to be careful about the direction of the encirclement. Direction of the encirclement. Okay. I hope it is clear. Conducting phase. Sir, a humble request. Please take analog topics and electrical machine topic and get. Okay, I will take it. Don't worry. Have patience. Okay. You have already provided ample amount of content on YouTube regarding. Okay. After control system, I will take that. Okay. We all know the very good teacher of core subject finally. Yes, I will take core subjects as well. Don't worry. Okay. I will take core subjects. That's my promise. Okay, guys. So this is the conclusion that you need to remember. Now, let's take a random question. Now, I want to take a random question. I want to ask you. I want reply from your side. Let's say this is S-plane contour. This is S-plane, and in S-plane, the contour is random like this. This is S-plane contour, and the direction of the contour is given like this. Okay, this is S-plane contour, and there is a function, there is a random function. That function you can call PS, and that PS is S plus Z1, S plus Z2, S plus Z3 divided by S into S plus P1, S plus P2, S plus P3. Okay. Now, PS is given to you, S-plane contour is given to you. The zeros are minus Z1, minus Z2, minus Z3, and the poles are minus P1, minus P2, minus P3, and one pole at origin. So these locations are given to you. Wait a minute. Okay, at this point, okay. Now, at this point, one pole is lying. Let's say two poles are lying here. One is here and one is here. Okay. P1 and P2. Minus P1. Let's call it minus P1. Let's call it minus P2. Okay. And there is one more pole. Minus P3. Okay. These are the pole location. And the zero location is 1, 0 is at this point. Minus Z1. Minus Z2. And there is 1, 0 here. Minus Z3. Okay. Let's say these are the poles and the zeros location. Poles and zeros location are provided to you. Now, if you map this S-plane contour into PS plane, you want to map this S-plane contour into PS plane. Now, tell me the number of encirclement of origin. Tell me, guys, what is the number of encirclement of origin? Tell me, what is the number of encirclement of origin? Tell me, everyone, what is the number of encirclement of origin? N we need to find. Number of encirclement of origin and the direction of encirclement. Tell me, guys, tell me the answer. Do it fast, everyone. Number of encirclement of origin and the direction of encirclement. You have to tell me that. Tell me, everyone, do it fast. Let's see how many of you can find it. Do it fast. You have to map this S-plane contour into this PS plane. And you have to tell me the number of encirclement of origin. Let's see. We know that the number of encirclement either P minus Z or Z minus P. Either you can apply this formula or this formula. Whichever formula give you the positive answer, that is correct. Now you can see that three poles are inside this contour. You can see that there are 3 poles. Inside this S-plane contour, there are 3 poles and 1, 0. 3 poles and 1, 0 inside this contour. It means P has to be 3 and Z has to be 1. So this formula I am going to use because it will give you the positive answer. It means P has to be 3 and Z has to be 1. So the number of encirclement will be 2. And since I am using this formula, poles are more than zeros. So the direction will be opposite to that contour direction, S-plane contour direction. Since the S-plane contour is clockwise, so here the encirclement has to be anti-clockwise. And there must be 2 encirclement of origin. There must be 2 encirclement of origin and it will be anti-clockwise. Okay. So you have to be very clear about that. 2 anti-clockwise. Okay, I hope it is clear, guys. I hope it is clear. So you have to be very clear about it. Now let's move to the next point. Let's move to the next point. So I told you about encirclement of origin, how to check the encirclement of origin. Now there is one more question. Let's try to solve one more question. And the question on your screen is, this is my S-plane. This is my S-plane and this is some S-plane contour is provided to you. Okay. This is some S-plane contour is provided to you. And there is some PS function. PS is like this. K0 into S plus Z1 into S plus Z2 divided by S into S plus P1 S plus P2 into S plus P3. It's like this. If you map this into this PS, then the resultant contour will be in PS plane, the contour is like this. This is the contour. And the direction is like this. This is the direction of the contour. Now, you have to tell me about the pole and zeros inside this contour. How many poles and zeros are lying inside this contour? Let's comment on that. Let's comment on that. Let's say some S-plane contour is given to you, and if you map this S-plane contour into PS, then the resultant contour will randomly look like this. Okay. Now, what I need to do is, I need to find the poles and the zeros, number of poles and the number of zeros inside this contour. How many poles and how many zeros will lie inside this contour? Now, look at this. How many encirclement of origin are? First, you have to calculate that. Since the mapping is given to you in the PS plane, you can find the number of encirclement of origin. How to find number of encirclement of origin? From origin, you can draw any line like this. Don't draw line via this crossing point, okay? Just draw the random line like this, okay? Now, on this line, it is cutting 2 times. The line is cut 2 times, and you can see that the line is cut in this direction. And this contour is opposite. This contour is anti-clockwise, and it is cut by in the clockwise direction. It means there are 2 encirclement. There are 2 encirclement, guys. The origin, there are 2 encirclement, and these 2 encirclement are opposite to that. It means formula has to be P minus Z. Is it clear, everyone? So P minus Z has to be 2. You can write like this. Why you have used P minus 2 Z? Because the encirclement of origin is 2 and it is opposite to this S-plane contour. This S-plane contour is clockwise, you can see. And this is anti-clockwise. This S-plane contour is anti-clockwise, you can see. And these are clockwise. Since it is opposite, that's why you have to use this P minus Z formula. It means 2 has to be P minus Z. It means the number of poles inside this contour are more than the number of zeros. Okay, let's say 1 zero is lying inside it. I'm not sure. There are 2 zeros. There are 2 zeros. If all the zeros are outside, now it can be an MSQ question. There can be 4 options. There can be 4 options. The first option is, let's say all zeros are outside the contour. All zeros are outside contour. Outside S-plane contour. Then only 1 pole out of this P1, P2, P3, only one pole should be inside this. Because this origin pole is already inside it, na? This origin pole is already inside it. Out of these three poles, minus P1, minus P2, minus P3, one pole, one more pole has to be inside it. Because the zeros are outside the S-plane contour. Zeros are somewhere here, or maybe some outside, I don't know, on real axis or maybe on complex plane or whatever. So if all zeros are outside the S-plane, then only one pole out of P1, P2, P3, only one pole has to be inside this S-plane contour. Now, number 2, if one zero is inside, if one zero is inside S-plane, tell me guys, then how many poles? If one zero is inside this S-plane contour, okay, then P has to be 3. 3 pole has to be inside this contour. One pole is already inside. So out of these 3, 2 pole should also be inside this S-plane contour. I hope it is clear. Now the next is number 3 option. 2 zeros are inside this contour, inside S-plane contour. Then tell me, if 2 zeros are inside this S-plane contour, then pole inside this contour has to be 4. It means all the 4 poles has to be inside this contour. So this way you can frame question. Yeah, it's a multiple select question. You can make each option as an answer. I mean, each answer as an option. Okay. So I hope it is clear. So this type of question you may see in the exam. This all depends on the mapping. Okay. So I think mapping is clear, guys. I think in this session we have understood the mapping part. Now in the next class, we will also try to understand the mapping again. But that time, we will map the entire S-plane. I will take the right half of the S-plane. This is the S-plane contour. Okay. This is j omega axis. Omega varies from 0 to infinity. And here, it is r e to the power j theta. R tends to infinity. And theta varies from plus pi by 2 to minus pi by 2. And then again j omega. Omega varies from minus infinity to 0. So in the next class, I will take this S-plane contour and I will try to map this S-plane contour into some TS function. Okay. So in the next class, we will do that. Okay. So we have done the basic mapping here. I hope you enjoyed. I hope you understood this basic mapping. So guys, I think today's time is over. So we'll continue from this point in the next class. Okay. Don't forget to subscribe our channel. Don't forget to like this session and press the bell icon so that you get the notification whenever my sessions are live. There is one important thing. We have our mobile app. Okay. We have our mobile app, BYJU'S Exam Prep. You can go to the Google Play Store and you can install our mobile app also. Okay. So that's all for today's session, guys. I hope you enjoyed. Don't forget to share this video to your friends and we will continue from this point in the next class. Next class will be again at 9 p.m. and it will be on tomorrow. Okay. So thank you. Take care. Bye.